bucka. Ha. You know the deal.
The next thing we're going to talk about in our algebra unit is something called the distributive law. To begin to explore the distributive law, we're going to take a look at an example here of a math question that doesn't involve any algebra. So here, if we look at this math sentence, we have a couple of things going on here. We've got some brackets where we have an operation inside of the brackets, and we have this number right next to the bracket. When we have the number right next to the bracket like that, that means that we're multiplying. So we're multiplying 5 times what's inside the brackets. Now, because we're just doing a regular math sentence here, it doesn't involve any algebra, we're not trying to isolate the variable, we do have to follow BEDMAS. So that means we have to solve what's inside the brackets first. So the next line of our solution means we have to do 2 plus 3 first inside the brackets, and 2 plus 3 is 5. And now we're able to multiply 5 times 5, which is 25. Well, when we talk about the distributive law, it usually involves a question that looks something like this, where we have a number being multiplied by something in the brackets. Now in this case, we were able to add what's inside of the brackets because those are like terms. 2 and 3 are like terms. They are able to be added and subtracted. But if we wanted to, we could have also skipped the brackets and gone straight to multiplication. The thing here, though, is 5 is being multiplied by everything inside of the brackets. So 5 is being multiplied by 2, and it's also being multiplied by plus 3. So if we wanted to, we could skip what's inside the brackets and just multiply 5 times everything inside the brackets. 5 times 2 is 10. 5 times positive 3, or plus 3, is plus 15. And when we add 10 plus 15, we still get 25. So we can see that whether we multiply 5 by everything inside of the brackets and then simplify, or solve what's inside the brackets and then multiply, we do end up getting the same answer. So you might ask yourself, well, why bother? Why not just do it this way? In the next example, we're going to see why we bother with that. So here we have a math sentence similar to the last math sentence in that we've got 5 being multiplied by what's inside of the brackets. If we go to follow BEDMAS, follow order of operations here, again, normally we would start with what's inside of the brackets. But as we discussed in the last video here, we cannot add those two terms together. X and plus 2 are not like terms. And this is where that distributive property that we saw in the last example comes in very handy if we want to simplify this. Because 5 is being multiplied by everything inside of the brackets, we can multiply 5 times x and 5 times plus 2. Now, when we multiply 5 times x, we can't actually solve that, but we can rewrite it as 5x. 5 times x and 5x are the same thing. And 5 times plus 2 is plus 10. So here's another example, and again here, if we wanted to follow order of operations, if we wanted to follow BEDMAS, we would have to start with what's inside of the brackets. Inside of the brackets here, we do not have like terms though. We cannot simplify 3x minus 8. So that means we actually have to skip brackets and move right to multiplication. And the multiplication here is 4 times everything inside of the brackets. So first we're going to take a look at 4 times 3x. Well, 4 times 3x, if you recall, 3x means 3 times x. So when we have 4 times 3x, what we have is 4 times 3 times x. And there is a part of that we can simplify. We can do 4 times 3. 4 times 3 is 12. We still have times x. That we can't really simplify, so we have to leave it as 12x. 4 times minus 8 is minus 32. And once again, that's as far as we can go because these are not like terms. So here's one final example here where, again, if we were to follow BEDMAS, we'd have to start with what's inside of the brackets. And inside of the brackets, we have 2x plus 3y. As discussed in the previous video, those are not like terms. We're not using exactly the same letter in those two terms, so we can't add 2x plus 3y. So that means we have to skip brackets and go right to multiplication. In this case, it's negative 3 times everything inside of the brackets. So first we have negative 3 times 2 times x. The only part of that we can simplify as negative 3 times 2. Negative 3 times 2 is negative 6. We still have times x, so we have to put that x there. And next we have negative 3 times positive 3 times y. Negative 3 times positive 3 is negative 9, and we still have times y. And once again, here we have a case where we don't have like terms. That's as far as we can go. We're not able to simplify that anymore. So to finish off our lesson on the distributive law, I'm going to ask you to answer a couple of questions here. So again, in each case here, if you were to follow order of operations, you'd usually start with what's inside of the brackets. But you'll notice inside of all of those brackets, we don't have like terms. So we have to use the distributive property and multiply that number on the outside of the brackets times everything inside of the brackets. The last one is a little bit tricky. 4x means 4 times x. So we're going to have to start by multiplying 4 times x times 2 times y. And there is a part of that that you can simplify. Similarly, for the second part, you're going to have to do 4 times x times 3 times z. And again, there is a part of that that you can simplify. If you're able to answer those 3 questions, congratulations, you now have a firm understanding of the distributive law.